Hi everyone, so welcome in this video. So in this video, we will try to understand the concept of a battery. Well, we have been using batteries in our day-to-day life, right? Each one of us must have used a battery. Well, batteries have been important, but they are even more important today. In fact, they are kind of powering the whole automobile revolution with all the electric cars and so many electric devices coming into being. So what is a battery? And when we go to a shop and we want to buy a battery, we see 9 volt, 15 volt battery. So what are these? What is this 9 volt, 15 volt? What this term means? So this is what we'll try to understand in this video. So let's take a simple example. So let's take this battery, right? So let's look at this circuit. So you have a battery and you have a bulb which is connected to the battery. When you switch on the battery, or when you switch on the circuit, when you connect the circuit, the bulb glows. So what happens? What happens when you connect the circuit? So when you connect the circuit, this battery ensures a sort of a constant flow of charge in this circuit, right? So that's the whole purpose of a battery, right? The role of a battery is to ensure a constant flow of charge. That is what a battery does. And we'll understand how the battery kind of ensures a constant flow of charge. Well, that's what is electricity, right? The whole concept of electricity is about sort of a flow of charge, right? We control that flow of charge, and by controlling that flow of charge, we have we power different devices. We generate electricity. The electricity which we get in our home. So what is that? It's kind of a circulation of charge, a circulation of electrons, which happens right from the power generation point where the electrons start to move to all our household, right? So it's just a circulation of electrons which powers all our appliances, right? It's not that in electricity we create charges. No, when we use electricity in our life, and all the power generators and all the power plants, they don't create electrons, right? They just create a mechanism through which they ensure a circulation of electrons, right? And that this circulation of electrons powers all our electronic devices, lights, bulb, refrigerator, etc. So that's the whole purpose of a battery also. The battery is a sort of a miniature power plant which kind of ensures a constant flow of charge in the circuit in which it operates, and that charge kind of powers our electrical devices, right? So that's the battery concept, or battery definition at a high level. So now we'll try to understand what this 15 volt, 9 volt, these all tags these all specifications which are associated with a battery, what does that mean? So in this section, we will try to understand this term 15 volt, which is associated with a battery when we go to buy it. So let's say we have this battery, and it is a 15 volt. It is a 15 volt battery, right? And let's say this is a circuit which is connected, from the battery, and we have a bulb which lights up. So let's try to understand what is this meaning of this 15 volt from a battery. So as you can see, this 15 volt, volt is the unit of electric potential. So this 15 volt is kind of the electric potential, of something related to the potential, right, in this battery. So before understanding the potential which this battery generates in detail, let's first go back to the basics, and let's try to understand what is electric potential. So I've created a separate video on electric potential where I've covered this whole concept in detail, but kind of let's recapitulate it. So I've given the link of that video in the description. So let's say we have a charge Q over here, and around this charge, at each point in the charge there will be an electric potential, right? So how did we define electric potential? So let's take 2 points A and B, and let's say this is sort of the infinity, very far distant from the charge Q, where practically there is no electric field from this charge Q. So from infinity, if we have to bring a charge Q, like another charge Q dash, for example, here in the vicinity of this charge Q, then I'll have to do some work, right? Because we know that when you keep two charges close to each other, Q and Q dash, and these two charges repel each other, right? So Q will let's say Q is positive and Q dash is also positive, then Q will try to throw away Q dash in this direction, right? Now if you have to make sure that Q dash is closer to Q, you will have to apply a force, right? So you'll have to do some work, right? Similarly, if you have to bring another charge at point A from infinity, then we'll have to do some work, right? And similarly, to bring like another charge at point B, we'll have to do another work, right? Now, as we can see, since point A is nearer to Q and point B is farther from Q, so from infinity, the amount of work we'll have to do to bring another charge Q dash at point A will be more than the work we'll have to do to bring that charge at point B, right? So we can say that this point A is at a higher potential because more work will have to be done to bring another charge here than this point B, right? So if you kind of go through that section, so there we have defined electric potential at a point as kq by r. So at point A, the electric potential will be kq by Ra, right? Ra is the distance of A from Q, and at point B, the electric potential will be kq by Rb, where Rb is the distance of B from Q, right? As you can see, since Rb is more than Ra, so of course this Va is more than Vb. So A is at a higher potential, B is at a lower potential, right? So there is a potential difference between these 2 points A and B, right? So since there is a potential difference between these 2 points A and B, so now what will happen? So this point A is at a higher level in terms of potential than at point B, right? So what is the meaning of this? So the meaning of this is that if you keep some charge, if you put some charge over here, then the tendency of the charge would be to go from higher potential to lower potential, right? Same way, like just think of like an inclined plane, right? So in an inclined plane, if you keep a ball here, what happens? The ball goes goes downward, right? The ball goes from this point, which is at a higher potential, than this point. The ball goes downward, right? So same way, in the concept of charge, this point A is at a higher potential than point B. So the tendency of charges would be to go from point A to point B, right? So this will be the tendency of these charges, right? Now, if you want to make sure that there is a continuous flow of charge from point A to point B, then you will have to make sure that you have infinite number of charges at point A, such that there is a continuous flow of charge from point A to point B. Or you have to ensure that, let's say you have only one charge, then that charge goes from point A to point B. Then again, you'll have to do some work to bring that charge back to point A. And again, that charge will automatically fall from point A to point B. Then again, you will have to bring some work to bring that charge to point A. And again, that cycle will complete, right? Just to again understand. So let's say you have one ball and this is an inclined plane, right? We're talking about gravity now. So if you drop a ball here, the ball will fall from here to the ground, right? Now, if you want to make sure that this ball goes in this whole cycle repeats continuously, then what you will have to do? This ball drops from this point A to point B. When the ball drops here, you will have to do some work to put that ball again here, right? And again, you will have to release the ball will fall. Again, you will have to do some work, to move the ball from point B to point A, and then you leave. Then again, you will have a continuous motion of ball, right? So same way in this charge also, a charge moves from higher potential to a lower potential. But if you want to make a constant motion of charge, then you will also need to do some work to move this charge from this point to this point, and then again you will have to leave the charge will fall, and again this thing will happen. This whole cycle will happen. So something exactly similar happens in a battery, right? So in a battery, you have two terminals, terminal A and terminal B. So just as A is at a higher potential than B, what we saw here. So terminal A here is also at a higher potential than terminal B. And so what happens? Because of that, if you drop a charge over here, then the charge flows, in the circuit, flows to the circuit, and the charge reaches point B, right? So the charge reaches from point A to point B, right? Now, the role of a battery is to ensure that there is a constant flow of charge. Then again, some work, like a battery does some work to move that charge from B to point A, right? From B to point A, as we saw that, we'll have to do some work because to move the charge from lower potential to higher potential. So the battery does some work to move the charge from point B to point A. And again, when the charge reaches point A, again the charge flows, right? So this is typically what happens in a battery, right? So this 15 volts which you see here, this 15 volts is the potential difference between these 2 points, between these 2 terminals of the battery, point A and point B, right? Now you might be wondering that, hey, but the potential is defined as, bringing a charge from infinity to a point A. Now here at this terminal A and terminal B of the battery, how are we bringing charge from infinity to A and at point B? Well, this whole bringing a charge from infinity to point A and point B is a theoretical concept. The whole idea is that the whole purpose of a battery is to make sure that there is a constant flow of charge, there is a potential difference, right? So as long as you are able to maintain a potential difference, as long as you are able to maintain a constant flow of charge, we can designate 2 points at a higher, like one point at a higher potential than the other point, right? Now how that potential difference is generated, we will discuss later. But the point is that in a battery we are not bringing any charge from infinity. That's a theoretical concept. Whole purpose of the battery is to make sure that there is a constant flow of charge, right? Because even when we are bringing this charge from infinity to point A and we did all that thought experiment, the ultimate goal is what? That we get 2 points. One point is at a higher potential, one point is a lower potential, and from the higher to lower potential, flow of charge happens, right? Similarly, in battery also, just the flow of charge happens. Now, when the flow of charge happens, then we can apply that theoretical concept and we can say that point A is at a higher potential, point B is at a lower potential, right? So just think of battery as a machine or as an equipment which kind of ensures that there is a constant flow of charge, right? So any equipment which does that is the battery, and because when that movement of charge happens, then we apply our learnings of electrostatics, potential and all, and we designate 2 points in that equipment as having different potential, right? So that's what is 15 volt. It's the potential difference between 2 points in the battery. Now, how is this 15 volt measured, right? How do we, because here we are not bringing any charge from infinity, right? Like what we are doing in battery, like in this circuit over here. In circuit, we have a proper way of defining potential KQ by RA. In the battery, we are not doing all that, no? We are not bringing any charge from infinity. And also, how is 15 volt measured? Because in a theoretical experiment where we put a charge and we bring a charge from infinity, we have a formula, and from this formula we can find 15 volt, 10 volt. But here we're not doing all that. So how are we measuring it? So for that we take the help of Ohm's law. So what is Ohm's law? So Ohm's law says that V is equal to IR, right? So the potential difference in a circuit is equal to the current in the circuit times the resistance in the circuit, right? So what happens when a battery is prepared, then a circuit is kind of completed and an experiment is done, and in that experiment the current which flows in the battery is measured. So I is measured. There is an instrument called ammeter. From that you can measure I, and a resistance is kept. So the resistance value is also known, right? So for a 15 volt battery, so let's say you have a battery and you are claiming that this battery is of 15 volt. So in that battery, if you connect a 15 ohm resistance, then so the battery's potential difference is 15, current is I, and you have connected a 15 ohm resistance, then ideally in that battery there should be a current of 1 ampere, right? So when you measure the current and you find that okay, the current is 1 ampere, then you say that okay, this battery creates a potential difference equivalent to 15 volt, right? So that is how this 15 volt is tagged to a battery. Now again I'm reiterating that here in battery we are not bringing any charge from infinity, and we are not doing all this exercise to create the potential difference, right? So how is this potential difference created in a battery, right? So that is what we will see in the next section. So let's try to understand how a battery creates a constant flow of charge or constant flow of electron or electricity. And because the battery creates a constant flow of electricity, battery has a potential difference which we saw earlier. So what happens in a battery is that this is a kind of a more detailed view of what is inside the battery. So in this battery you can see there are two nodes, A and B. So these nodes are essentially shown in this diagram as A and B. So node A is called anode and node B is called cathode. So node A is kind of generally made of materials like zinc. So this node A is made of a rod like a zinc rod, which is inserted in a zinc sulfate solution. So in this solution you will have zinc plus ion and SO4 2 minus ion, right? So this in this solution there will be zinc ions and sulfate ions. Similarly, this copper rod, which is point B, this rod B is kind of immersed in a copper sulfate solution. So here you will have copper ions and sulfate ions. So Now what happens is that like zinc and copper, like each even in this rod, there will be zinc atoms, right? There will be copper atoms, and we know that atom has a nucleus, and around the nucleus you have you have electrons which orbit the nucleus. So and the nucleus contains protons and neutrons. So the protons kind of attracts the electrons, and so the electron kind of move in this in an orbit. Now each atom, has like attract these electrons which rotate in the orbit by a different force, right? So copper attracts the electrons by a larger force than zinc. So copper has a higher affinity for electrons than zinc, right? So each metal can are ranked in that order. So since copper has a higher affinity for electrons than zinc, so when you connect this copper and zinc rod, then copper will try to pull electrons from zinc, and so what happens when the copper will pull electrons from zinc. So there will be a flow of electron from zinc to copper, like in this direction there will be flow of electrons. So when the flow of electrons will happen, then what will happen from the zinc rod? The electrons will flow. So at the zinc rod you have zinc, but now you have the electrons will flow. So you will have zinc ions will get created plus 2 electrons. So these electrons will move from zinc to the copper rod. Now in the copper rod, these electrons will reach, right? So when these electrons will reach, so you have copper ions here, right? So you have copper ions and sulfate ions. So you have you have these copper ions which are like this. These copper ions will get these electrons, right? And they will become copper atom, right? So what will happen here from the zinc rod? The zinc, two electrons will move from zinc to copper, so there will be zinc ion which get created. Now the zinc ion will kind of move from the rod to the solution, right? Because ions cannot remain like inside this rod, because the ions the zinc ion will move into the solution, because ion is charged, right? So it cannot stand on its own. Now in the zinc rod, the zinc atoms stand on their own. The moment they become zinc ion, so they cannot stand on its own, so they will go into the solution, right? So zinc will become zinc ion and copper, and in the copper rod, these 2 electrons will reach. So you have various copper ions here already, because you have this copper sulfate solution. So what will happen? These copper ions, they will get the electron, and then they will become copper atoms, right? They will become copper atoms. So over time, what will happen? That more and more, like this whole reaction will continue. This whole process will continue. So over a period of time, what will happen? The zinc rod will become thinner and thinner and thinner, because from the zinc rod, zinc ions are getting generated and they are getting into the solution. And on this copper rod will become thicker and thicker and thicker. So what will happen? The copper ions which are inside the solution, they will get accumulated on the copper rod, and so this will become thicker. Now beyond a point, this will happen till a point, and then the moment the zinc rod becomes very thin, or the ions inside the copper solution become very less, the cell will not function. So that's why you have this 15 volt or 9 volt battery. So they work for a particular duration. After that, they become dysfunctional. So why would they become dysfunctional? Because of this reason, right? So that's how. Now as long as this battery is able to transport electron from zinc to copper, the battery will ensure that there is electricity. When this flow of electron happens, so here you can connect a bulb, right? Now as the electrons will flow through this, the bulb will glow, right? So what is this battery doing? This battery is kind of ensuring a flow of electrons, right? And what is happening? So like if you remember in the previous section, what did I say? That essentially what is happening is that this zinc is like you have 2 points A and B. The point A is at a higher potential than point B, so charge will move from point A to point B. But then to make sure that you have a continuous flow of charge, charge comes from point A to point B, but again, to make sure that the flow is continuous, you'll have to bring the charge, you'll have to do some work to bring the charge again here, and then again the charge will flow, right? So here again, charge, so there are, there is point A and there is point B, so charge is flowing from so electrons are flowing from point A to point B. So essentially, negative charge is flowing from point A to point B. So positive charge, we can say that, is flowing from point B to point A, right? Because negative charge is flowing from point A to point B. So in a way, we can interpret it as positive charge is flowing from point B to point A. Whatever is the positive, let's leave that positive negative thing. Electrons are flowing from point A to point B. So to make sure that this flow is continuous, there will have to be some work which will need to be done. So where is this work coming from? So this work is coming from this chemical reaction, right, which is happening inside the cell. Now work can be of any form, right? This is a chemical reaction which is sustaining this this continuous flow of electron. So that's how this battery works, right? So that's how this battery is able to create a constant flow of electron, right? So again, remember, the goal of a battery is to ensure a constant flow of electrons. So again, it's not that from infinity you are bringing a charge and then you are creating a sort of a potential difference. No, you take any device, and in that device, if you are able to create a constant flow of electron, then you can use the electric potential concept, and then you can apply, you can associate a potential difference, right? So the ultimate goal is to ensure that, to come up with a device which ensures a constant flow of electron, and that's what a battery does. And the battery which we use, in that battery, this sort of electrochemical reaction happens, right? Now, at this, there are some more nomenclature which I think it's good to know that this point A, this zinc, this zinc rod loses electron, right? So the reaction which happens at the zinc rod is called oxidation. It's called oxidation, right? And copper rod, at the copper section, it gains electron, right? So the reaction which happens, it's called reduction. So this battery, oxidation reduction reaction happens, right? So this battery is called chemical battery, and in this battery, this oxidation and reduction reaction happens. So that's how typically a battery works. So I hope that this concept of battery would now be clear to you, and thanks for watching.